Quick, graph y equals the sine of the quantity 1/2 times x by hand 2 different ways. This is part of the family of functions series. You will need paper and a straight edge, or you can download this PDF and print it. Press pause as needed anytime during the video. Graph y equals the sine of the quantity 1/2 times x. The first way is with what we call the Sine Dance. Recall the graph of the sine function and the 5 key points of interest. These key points are affected by the parameters in the equation, as all of the points on sine graph are. The only parameter here is 1/2 inside the parentheses. That coefficient of x, we'll call it k equals 1/2 inside the parentheses. That affects the width of the period, and it does it inversely. The horizontal dilation factor, you may recall, is the reciprocal of that value of k, or in this case the reciprocal of 1/2 is 2. Now the period of the sine is normally 2 pi. For this graph sine of the quantity 1/2 x, the period is going to be 2 pi times 1 over k, 2 pi times 2, which is 4 pi. Pause is needed. Again, the period is 4 pi because of that 1/2 coefficient of x there. We're going to need to use a different scale along the x-axis. We suggest marking off every pi and going from negative 4 pi to 4 pi as the domain. Pause is needed. The initial point on the sine graph is at the origin, 0, 0, and that point is unaffected by the 1/2 coefficient, so we'll plot at 0, 0. We look at the end of the period point. It's a point of inflection at 2 pi, 0. But remember, our period is 4 pi away, so the end of our first period is going to be at 4 pi, 0. Halfway between the initial point and the end of the period is another point of inflection, normally at pi, 0. Halfway on our graph, though, it's at 2 pi, 0. Halfway between these two first points of inflection is a maximum at pi over 2, 1. But similarly, halfway on this graph, the maximum is going to be at pi, 1, halfway between these 2 points of inflection. Halfway between the second and third points of inflection is a minimum, normally at 3 pi over 2, -1. On our graph, halfway is going to be at 3 pi, -1. Pause is needed. Connect the points as a sine wave, a frown or concave down, a smile, concave up. This is one period of the sine wave. Let's duplicate the wave in the negative direction. So we're going to go back one period, 4 pi, from that point of inflection. From this point back 4 pi, another point of inflection back 4 pi, and from this minimum 4 pi. Connect the points as a sine wave, concave down, concave up. Compare that to the parent function. This is the sine waving along. And you can see we have a lot more waves on the blue sine function than we have on the graph that we just did. So here's one period right here, and in that same width, we're only going to get half the period of the sine of a half x in the same width. And the reason is that coefficient of x there. Pause is needed. So let's generalize. The period of a sine wave is normally 2 pi. But what about the period of an equation of the form y equals sine of the quantity, some constant, which we'll call k, times x? You might recall, since k affects the period inversely, the normal period is multiplied by the reciprocal of k. That is, the period of y equals sine of the quantity k times x is going to be 2 pi over k, which is 1 over k times 2 pi. Again, the period of y equals the sine of a constant times x is 2 pi divided by that constant. Now, this is a big deal. Probably should write it down and remember it. Press pause as needed. Let's go ahead and see if we can apply this. Here are 3 examples here where we give the equation in terms of sine, and we want you to just state the period of each of the following. Pause as needed. Resume when you're finished. For the first one, the period is 2 pi over k, which is 2 pi over 3. So this is kind of much shorter than the normal sine graph. Sine of the quantity 4x, the period is 2 pi over 4, which simplifies to pi over 2, even narrower. But for the sine of 1/3 x, 2 pi divided by 1/3 is the same as 2 pi times 3, which is 6 pi. So it's horizontally stretched quite a bit. Pause is needed. The second way of graphing y equals the sine of the quantity 1/2 times x is using a table. So these are our axes values. Go ahead and complete the table. Pause is needed. You should just know these values here. We need to create a second table for our graph. And we look at the parameters, and that coefficient of x, 1/2, inside the parentheses, affects the width or period of the graph inversely. We need to multiply each x value by the reciprocal of 1/2, which is 2. We're also going to need to change the units along the horizontal axis because of that too. We're suggesting you mark off every pi and go from -4 pi to 4 pi as the domain. Pause is needed. And we're going to have a graph looking like this. So we're going to multiply each x value by 2, so 0 times 2 is 0. The y-coordinates remain unchanged, so it's going to be 0, 0, and we'll plot the origin. The next x-coordinate, pi over 2 times 2, is pi, comma 1. Pi times 2 is 2 pi, comma 0. 3 pi over 2 times 2 is 3 pi, comma -1, a minimum. 2 pi times 2 is 4 pi, comma 0. Pause is needed. Connect the points as a sine wave, concave down, and then concave up, with 2 pi being a point of inflection, where curve changes concavity. This is one period of the wave. Plot another one to the left. So we'll go back 4 pi to the left from each of the points of interest. And then connect the points as another sine wave. Concave down, concave up. And compare it to the sine function, the parent function. Now you try one. Graph y equals sine of the quantity 2 times x. Use either method or both for the practice. Also, what is the period? Pause is needed. Resume when you're finished. And there's our graph right here in green. The period is pi. 2 pi over 2 simplifies to pi. And we marked off the axis every pi over 4 for clarity.